This conference will now be recorded.
All right. In this session, we are going to look at the architecture of Oracle database. Architecture is very complex and very important. Proper understanding of architecture is the foundation for effective database management skills. Architecture is so complex that even if you learn after 10 years also, even if you read the architecture after 10 years also, you find some new points. So it's very complex, and initially it might take some time to fully understand and appreciate Oracle database architecture. But the aim here is at least we'll understand the basic terms, basic concepts. But as you dig deeper into the architecture, you'll find it more complex, more interesting, and okay. No matter whatever you read, you feel that you still need to know more about Oracle database architecture. So that is the kind of topic. So let us start understanding the high-level architecture of Oracle database. Oracle database, is a relational database management system that manages the storage, organization, and retrieval of data. Every Oracle database consists of two things: a database and at least one instance. So you can see in this slide, we have database and we have instance associated with each other. Normally, an Oracle database will have a single instance, but an Oracle database can have multiple instances also. So accordingly, we have single instance database or the regular Oracle database, or multi-instance database, where a single Oracle database will have multiple instances. So this type of database is also called as a real application clusters database, RAC database. Before you understand the RAC database, before you master RAC database, first you should master single instance database. So in this training, we are learning about a single instance database. Once you learn about a single instance database, you can go ahead and easily learn about a multi-instance database.
Okay.
So let us learn more about these terms, database and instance. So starting today, every day, we use these terms. Instance. Every Oracle database will have at least one instance. So what exactly is an instance? An instance consists of two things: memory structures and background processes. Because instance consists of memory structures and processes, instance runs in the memory of the computer system. Instance exists in the main memory. Database consists of files. Every Oracle database consists of various files. The most important files of an Oracle database include control files, redo log files, and data files. Apart from these files, an Oracle database also uses various other files, like password file will be there, parameter file will be there, archived or redo log files will be there, flashback log files will be there. But control files, redo log files and the data files are the main files of an Oracle database. Because files are created on the storage, right? So database exists in the storage system. Instance is in memory, database is on the storage. So as shown in this slide, you can see we have the database servers and we have memory. In memory, we have instance. And now we know instance consists of memory structures and the background processes. And the database consists of files, and every file exists on the storage. So this is the storage, the hard disk. So database exists on the storage, and the database is nothing but set of files. How many files? What is the size of each file? Or how much instance, the size of instance, okay, how much memory should be allocated to instance. These are all configurable. These are all configured by the DBA. And anytime you can change the uh, configurations. Most of the configurations can be changed at any time. Some configurations are fixed. So, having understood that every Oracle database has two components, one is the database, second one is the instance. Let us learn more about instance. Every Oracle database has an instance. So when you start the database, the instance is started. And applications access the database through instance. So applications are users, database users connect to instance and access the data from the database. So it's like a door to the database. Without instance, you cannot access the data present in the database. So as we discussed, an Oracle database instance consists of memory structures and background processes. So let us learn about these memory structures and background processes. Instance memory structures include two things called System Global Area, SGA. This is the main memory structure. SGA is a shared memory. The second memory structure of an Oracle instance include Process Global Area, PGA. PGA is a private memory. So one is shared memory, second is private memory. So you know shared meaning. Shared memory means anybody can use that. Any process can use that. Private memory is private. Only a particular process can use that. So Oracle database memory structures, okay, include SGA, which is a shared memory region. Second is PGA, which is a private memory.
Okay.
So you can see in this diagram, we have instance, which includes memory structures and background processes. And these memory structures are elaborated here. Okay, and you will learn at a later stage about these background processes and server processes. So every Oracle database also includes various processes, mainly the background processes and server processes. So all these processes use SGA and PGA memories. SGA, you can see here, System Global Area. There is a red rectangle, the big rectangle. So this is the SGA memory, which is the main memory of an Oracle database instance. So all these processes, these background processes, these server processes, sharedly use this memory. So that's why it is called shared memory. It is a shared memory. Any process can use this memory while in operation. On the other hand, we have PGA memory. Every process, this background process and server process, can have private memory specific to that process only. Suppose you can see in this picture, there is a small red rectangles or PGA memories. Each, suppose we have three server processes in this diagram. Each server process has its own PGA. Only that server process can use that PGA. So that way it is a private memory which is accessible to only that particular process. So every background process and every server process can use private memories. So all these PGAs put together is called instance PGA. So as more processes are started, more PGA memories may be used. So at any point in time, all these PGAs put together is called instance PGA. So you will learn more about the background processes and server processes in the next few slides. In fact, that is what we are going to learn now. So before we learn background process or server process, which are Oracle processes, first of all, what is a process? Process is a very commonly used term in computing world, in IT, right? Basically, a process is a mechanism in an operating system that can run a series of steps. In general, processes run code. Okay. So process normally runs in its own private memory area. So when you start an operating system will have many processes. Similarly, when you start an application can start its own processes. Each process executes the code and uses memory of the computer system. So a process may consume a small amount of memory, another process may consume big amount of memory, but every process use memory. So as more processes are started, memory consumption goes up. So that is the basic definition of a process. Now in Oracle world, process has very important role. Oracle database, in Oracle database, we come across two types of processes. One is the client process. Second is Oracle process. So these are the two types of processes that you come across in database. Client process runs application code or Oracle tool code. So client process is started on the client system. Client system is where application code is executed. So normally database clients access the database from a different computer system. Though a client can be on the same system as the database, normally client systems are different. So when you run the application to connect it to the database, the application code has to be executed on the client system. So client system starts the client processes that run the application code. Or if you don't have application, you might use Oracle tool like SQL Plus. SQL Plus is an Oracle tool to connect it to Oracle database. So you start SQL Plus on a remote system to access a database running on a different system. So whatever may be the case, client processes are on the client system and they run the application code or Oracle tool code. Then Oracle processes. Oracle processes run on the database server and runs the database code. So here in this diagram, you can see we have a client system on which application is installed. And when you start this application, client processes will be started on the client system. Then on the other hand, we have database server. We have database and instance. And we have Oracle processes on the database server. Oracle processes are part of your instance, right? So that is client process and Oracle process or database process. So now let us learn more about Oracle process. We are interested more on Oracle processes because as a DBA, you need to know Oracle processes which are on the database server. Client processes are started whenever you start the application and execute the application code. Again, Oracle processes include server processes and background processes, which are very important for the functioning of an Oracle database. So every Oracle database has two types of processes, server processes and background processes. So let us learn more about these two types of processes. First, the server process. Server process is also called as foreground process and performs work based on a client request. So when a client system on which application is installed is connected to database, Oracle database automatically starts a server process. So when client connects to database, database starts a server process. This server process handles all the requests from that client. For example, a server process, okay, does parsing and running of SQL statements. When your application submits SQL statements, the server process running on the database server parses this SQL and runs this SQL, retrieving and returning results to the client program. So whatever the client asks for, that is served by the server process. Just to understand this more effectively, you can compare the server process to a server in the hotel, right? As shown in this slide.
Yeah.
You go to a restaurant, you want to order something. So the server will come and take your order and serve your request. So whatever you order will be served by the server. So that is something very similar to that. So every application, every connection will have a server process allocated by Oracle database. Suppose now one user connected to database. That means I have one client connection to the database. So I will have one server process started by Oracle. Now another user connected to the database. The second user connected to the database. Oracle database starts a second server process. So as more users are connecting to the database or more applications are connecting to the database, more server processes are started by Oracle database. And server processes are automatically closed by Oracle database servers whenever a connection is closed. Now suppose I have two users accessing the database. You will have two server processes. One user disconnected from the database. So now you will have only one server process. So that way server processes are automatically started by Oracle database as and when a connection request is made. Similarly, a server process is automatically stopped by Oracle database whenever a connection request is closed, a connection is closed.
Okay.
And the server process handles all the requests from the client. Similarly, we have background processes. These are the main processes. These are the uh, foundation for your Oracle database. Background processes are
Okay.
very important, and they run the show. Background processes perform maintenance tasks required to operate the database. Each background process has a separate task but works with other processes. Oracle database creates background processes automatically when a database instance starts. So apart from server process, which is the foreground process, we have background process. We have many background processes which are automatically started when you start the database instance. And background processes, we have many background processes. Some are compulsory, some are optional. Each background process performs a certain task but works in coordination with other background processes. So extending our earlier example, now you go to restaurant and who serves you? The server. But in the background, actual dishes are prepared by other staff. You have many other staff in the kitchen. Those staff, okay, you can compare as background processes. They does the actual work, right?
Right.
So you have chef,
Right.
you have cleaner, you have some other staff. So they all work together to prepare your dish. But finally, your dish is served by the server. So generally, you see server, but not the background staff, right? Background staff work in the background, and depending on the business, you may have many background staff, right? Similarly, Oracle
Right.
database also uses background processes, and the server process is front-ending process. That's why it is called foreground process. You see server process, you submit requests to server process. Server process works with the background processes to fulfill your request. That is about server process and the background processes. Another important difference is background processes are automatically started by Oracle database when you start the instance. They start along with instance, they stop along with instance. So whenever you stop Oracle database instance, in other words, you shut down the database, the background processes will be stopped. As long as the database is running, background processes will be running in the background continuously, waiting for the right time to perform their job. On the other hand, server process will be started whenever a user makes a database connection, not when you start the database. That is one important difference that you need to understand. So
Can
I
you repeat
started
that?
database.
The back.
Yep.
No, the last sentence. Can you repeat that? When when a
Server
user.
processes. Yeah,
Mhm.
let me repeat. Server processes will be started when when a user connects to the database,
Right. Yeah.
when a connection request is made. On the other hand, background processes are started when you start the database. Irrespective
Okay.
of
Got
users are connected or not, background processes are started.
it. Okay.
Okay. So suppose now I started my database. At 9 o'clock, I started my database. All the background processes will be started. Now 10 o'clock, the first connection is made. So at 10 o'clock, one server process is started. Okay, so 9 to 10, there are no connections to the database. That means 9 to 10, there are no server processes started. But 9 to 10, you have background processes started and running in the background. Yes. So that is one important difference that you need to understand. Again, 10 o'clock user connected. At 10:30, the user has logged off, disconnected from the database. So the server process is closed at 10:30. Now again, you don't have any server process. Suddenly at 11 o'clock, 10 users connected to the database. So at 11 o'clock, you will see 10 server processes started by Oracle database. So as more users are connecting to the database, more number of server processes will be started. Means more memory consumption happens. Once a user disconnects from the database, the server process is closed, releasing the memory consumed by that server process. So that way, as more users are connecting to the database, meaning more applications are accessing the database, the load on the database increases, the memory consumption goes up, and once the connections are disconnected, the memory consumption will come down. So you got the basic idea about these two processes, server process and the background process. Now, so this is something about the instance, right? The first understanding, first part understanding about your instance. So basically, just to recap, instance has memory structures and background processes. Memory structures include SEA and PGA. SEA is shared memory, PGA is private memory. And Oracle database has two types of processes. Client process runs on the client system and executes the application code or tool code. Oracle processes run on the database server. Oracle processes include a server process and a background process. Server process uh, is started whenever a connection is made to the database and handles all the requests from the client. Background processes work in the background and work together to complete the task. Server process is started whenever database connection is made. Server process is closed whenever you disconnect from the database. Background processes are started automatically when you start the database and stopped automatically when you shut down the database. There may be many background processes. Depending on the configuration, you will see many background processes started. So having understood something about the instance, now let us understand something about the database. Now the second part of an Oracle database is database, the actual database. Oracle database, okay, is basically storage, right? You know, database, the main purpose of database is to store the data. So to store and manage the data, Oracle database uses physical storage structures, logical storage structures. So Oracle database uses two types of storage structures to store and manage the data. One is the physical storage structures. Second one is the logical storage structures. So let us understand both these terms. The physical storage structures include files. Oracle database has three primary files: data files, control files, or redo log files. So these files are called as physical storage structures. Why physical? Why they are called physical? Physical storage structures are viewable at the operating system level. You can see these files at OS level. Physical means anything that can be viewed, right? Logical means
Yeah.
which is imagined, which you cannot view. So all these files,
Okay.
any file you can see at OS level, right? So that's why
Yeah.
they are called physical storage structure. Suppose when you create a data file, it is visible at OS level. When you create a control file, it is visible at OS level. So all these database files are visible at OS level, operating system level. That's why they are called physical storage structure. So ultimately, your data will be stored in one or more files. So every database has three types of files: data files, control files, redo log files. In fact, at a later stage, each one is a separate topic in our training. Data files is a separate topic. We'll spend 1 or 2 days on data files. Then control files is another topic. We'll spend 1 or 2 days on control files. Similarly, redo log files, 1 or 2 sessions on redo log files. So each one would be a separate topic in future. So most of these terms that you learn in architecture, come across architecture, will be a separate topic at a later stage. So for now, just we are trying to get acquainted with the basic terms, the basic concepts. Now, let us talk more about the physical storage structures, nothing but your data files, control files, and the redo log files. Data files, as the name suggests, stores the data. These are the main files of an Oracle database. So depending on how much data you store in the database, a database may have many files, many data files. Suppose a small database may have 10 data files. Another database may have 100 data files. Another database may have 200 data files. So depending on the amount of data that you store inside the database, a database can have many data files. And the file size is decided by the DBA. So DBA can add a data file at any time as per the requirements and change the size of the data file at any time or delete the data file if not required. So that is part
Okay.
and parcel of the database management system. Control files. So apart from data files, Oracle database also uses two other files. One is control files. Control files doesn't store data, okay, but store some controlling information about the database, some information about the database, like the database name, the database ID, the database creation timestamp, when this database was created, the database mode, whether it is running in archive log mode, no archive log mode, and information about the data files, redo log files, archive, archiving information. You will understand what is archiving, checkpoints information, backup information. So control files stores various information about the database. And this information is very critical for the operation of a database. In fact, when you start the database, the first file Oracle uses is control file, not the data file. So without a control file, you cannot even start the database. But remember, control files doesn't store your business data, your application data. Application data or business data is always stored inside the data files. So that's why data files may be very huge, big. They are very big in size depending on the data that you store. Okay, they may run into gigabytes or terabytes, whereas control files are small files. Typically in MB, their size is in MB, 10 MB, 20 MB. Okay, initial size will be automatically decided by Oracle when you create the database, which is around 10 MB. Okay, later it might grow in size, but generally control files are the smallest files. Among these three, Control files are the smallest files.
Okay.
Then redo log files. Every Oracle database has redo log files. Now, redo log files stores something called a redo data. Redo data is nothing but a description of changes made to the database. So when you store data inside the database, you not only store the data, you modify the data from time to time. Any modifications done to the database are recorded separately in redo log files. So these modifications or these changes made to the database is also called as a redo data. Actually, this redo data is used during recovery to apply the changes. Okay, so you made changes to the database, you lost the database. You have backup, you will restore that backup and apply the changes made to the data, which is nothing but your redo data. So again, at a later stage, each topic is a separate topic, each file is a separate topic. You will learn more about redo log files, how these changes are captured, used during recovery, and all that. So for now, redo log files stores redo data. What is a redo data? Redo means do again. Okay, you made the change to the database, you lost the database, you want that change back, right? So you restore the backup and apply the redo data to bring that change back into the database.
Okay.
So that way, physical storage structures include data files, control files, redo log files.
Okay.
Then the second one is logical storage structures. Oracle database allocates logical space for all data in the database. So when you store the data in the database, the space, the physical space is allocated using logical units. The logical units of database space allocation are data blocks, extents, segments, and the table spaces. These are the logical units of space allocation, also called as logical storage structures. The logical storage structures are created and recognized by Oracle database and are not known to the operating system. So you cannot view logical storage structures at OS level, whereas you can view physical storage structures at OS level. So logical storage structures are known to Oracle database only. They are not known to operating system. At a physical level, data is stored in data files on the disk. The data in the data files is stored in operating system blocks. Right. Now,
Okay.
just to take an example to better understand these logical storage structures. Forget about Oracle database. You want to allocate some space. Okay. Uh, Suppose you are purchasing a flat,
Okay.
right? You have physical space in the form of floors. Okay. Suppose you have 5 floors in the building.
Okay.
How is this space allocated? This physical space in the form of, say, square feet. Suppose
Yes.
you might purchase 1,000 square feet. I might purchase 500 square feet. Or if you take land, land is allocated in, suppose you have huge land, okay? Some 10 farmers want to purchase this land. How this land, this is a physical, right? You have huge land, physical land. You can see that land. How is this land allocated to these farmers in terms of acres? You might purchase 1 acre, I might purchase 2 acres, or guntas, right? World terms, 10 guntas, 20 guntas. So these
Hmm.
are the logical units of space allocation. Okay. So
Okay.
database uses the physical structures. Okay, all the data is stored inside the physical structures, the files. But when data is allocated to a particular object like a table, suppose you created a table, Oracle has to allocate space to this table from the physical file. How that space is allocated? That space is allocated in data blocks, extents, terminology. So these are the logical units of space allocation. Data blocks, extents, segments, and table spaces. So let us learn more about these logical storage structures.
Okay.
Data block or Oracle data block is the smallest logical unit of data storage inside Oracle database. One logical data block corresponds to a specific number of bytes of physical disk space. So data block is the smallest unit of logical space allocation. Like you can imagine as a square feet. So when you purchase a floor space, it is allocated in square feet, 1000 square feet, 2000 square feet, like that, right? Square feet is the minimum unit of space allocation. So here data block is the minimum unit of space allocation in Oracle database. Suppose data block size is set to 8 kilobyte. Normally the default value is 8 kilobyte.
Okay.
So that means when you create a table, the minimum space Oracle can allocate is 8 kilobyte. It cannot allocate below that 5 kilobyte or 4 kilobyte because your data block size is set to 8 kilobyte. Similarly, suppose you set the database block size to 4 kilobyte. Now the minimum space Oracle can allocate to any object is 4 kilobyte.
Okay.
Right? And this block size is set at database creation by the DBA.
Okay.
And later you cannot change the block size. So if you want to change the block size, you have to recreate the database. Of course, nowadays Oracle database supports multi-block sizes. Okay, with that, you don't need to recreate the database. You may create one table space with one block size, another table space with another block size. Okay, we'll come across all these things in future when we talk about data files. Now, the next logical unit is extent. Extent is a set of logically contiguous data blocks allocated for storing a specific type of information. Now again, though data block is the minimum unit of storage allocation, space is always allocated in extents, which is nothing but collection of data blocks. Suppose 100 data blocks is one extent or 20 data blocks is one extent. Okay, that is extent. Now it is again something similar to when you purchase a space, though square feet is the minimum unit. You don't purchase 1 square feet, right? Generally you may purchase 1000 square feet, 2000 square feet, 1500 square feet. So that is something similar to extent.
Okay.
So extent consists of data blocks, 100 data blocks, 20 data blocks, depending on the extent size. Now, next is segment. Segment is set of extents allocated for a specific database object like table. Now, when you create a table, Oracle database allocates initial space in the form of extents. Suppose Oracle allocated some 64, one extent whose size is 64 kilobyte. Suppose data block size is 8 kilobyte. So that means this extent will have how many blocks? 8 blocks. 64 kilobytes, right? Yeah. Now like that, first extent size is 64 kilobyte. Once this space is consumed, Oracle allocates another extent. Suppose the second extent size is 100 kilobyte. So now your table has two extents. One is 64 kilobyte, second is 100 kilobyte. Together, these
Okay.
two extents together are called as segment. So now your table has a segment whose size is 64 plus 100, 164 kilobyte. So at any point
Okay.
in time, all the extents allocated to a particular object is called as the segment of that object. So when you create a table, Oracle will allocate initial extent. Once you fill that extent, once you consume that space, another extent will be added. Again, once you consume that extent, another extent will be added. So like that, as your table grows in size, more and more extents will be allocated to your table. All these extents put together is called a segment.
Okay.
Then table space. Table space is a database storage unit that contains one or more segments. Now, segments are allocated in a table space. So every database at a high level will have table spaces. And a table space will have data file, one or more data file. And the data file space is allocated in extents. Extent is made up of data block. And collection of all the extents is called as segment. So that is how you need to understand these terms. So initially they may be a little bit confusing, but as you work more and more, as you spend more and more time on Oracle, these terms become a routine. So in a
Okay.
way, they are rolling up. Data block, okay, multiple data,
Yeah.
one or more data blocks. An extent is made up of data blocks, right?
Mm.
Segment is made up of extents, and the segments are contained inside table space. So they roll up
Table.
into each other. Data block rolls up into extent, extent rolls up into segment, segment rolls up into table space. So data block is
Okay.
the smallest, next is extent, next is segment, and next is table space. Now, to understand the relationships among these logical storage structure, here you have one example. Don't worry too much about these at this stage of learning. Here the intention is not to fully understand these concepts. Whatever you can grasp, that is good enough, because later we'll spend more time on these uh, topic. Okay, you will come across these at a later stage, and we'll spend a full time on this, understanding data blocks, extents, segments, and we'll have practices also.
Okay.
Now you see this slide. Here we have a table space, which is not shown in this slide, and this table space has a segment. Segments are contained
Mm.
inside the table space, right?
Right.
Uh, Suppose this segment size, this table space has two data files. Okay, data file, and we have created a one table, and it has a segment, and this segment has two extents. One extent on the first data file, second extent on the second data file. So these extent sizes are also shown here. So the
Different.
first
Yeah.
extent size is 24, second extent size is 72 kilobyte. So segment is nothing but sum of these extents. So 24 plus 72 is 96.
Right.
Now, drilling down further, an extent consists of blocks, right? Now
Yeah.
here, assuming that you have created Oracle database with 2 KB block size. So this extent has 12 blocks, okay, each 2 kilobyte. So 12 into 2 is your 24 kilobyte. Then this extent, the second extent size is 72 kilobytes. Means
Okay.
it should have uh, 18 data blocks, right? 18, sorry. Um, how much? 30,
That six.
32, 31, sorry. 31 into 2 is 72 kilobyte. So you have 32
36.
blocks.
Yeah.
Yeah, 31 or 32? 31. 31 into 2 is 72, right? Sorry,
That's
36.
yeah.
Okay. 36 into 2 is 72. So you have 36 blocks that make up this extent. So that way, block is the smallest unit. Okay.
Okay.
Extent is made up of blocks, and segment is made up of extents, and the segment is contained inside the table space.
Okay.
So that is the relation among all these logical storage structures. As I told you, uh, this is first time you are going through these concepts. So whatever you can understand now, that's fine. But don't worry too much about them because we will be understanding them in detail at a later stage. For now, just try to remember these terms, the terminology. You should be acquainted with the terms like what is physical storage structure, what is logical storage structure, block, extent, segment, okay, data file, control file. So become familiar with these terminology. So understand that Oracle database will have data files, control files, redo log files. What is there
Sure.
inside the database, how you manage database files and all that, you will come across at a later stage
Sure.
like that. Okay. Now, now this slide shows you the relation between logical storage structures and physical storage structures using crow-foot diagram. So here the physical storage structures are nothing but your files, data files, primarily the data file,
Yeah.
right? And the logical storage structures, you can see at the lowest level you have Oracle block. Next
Yeah.
to block you have extent. So you see this relationship. It is one is to many relation between extent and a data block.
Yeah.
Multiple data, many data blocks make up one extent, or in other words, one extent will have multiple Oracle blocks. Then extent rolls up into segment. A segment is made up of multiple extents. Then a table space will have multiple segments. And Oracle allocates the space in the data file in the form of extents. So when you create a table, Oracle allocates space in the form of extent. So a data
Okay.
file space will be allocated in the form of an extent. Again, Oracle data block is made up of operating system block. Operating system also uses OS block to manage the disk space. Ultimately, space is allocated and managed by the operating system, right? So Oracle has its own block, OS has its own block. Both are different. Both are different.
Okay.
Oracle block is set by DBA. OS block is set by the sysadmin when you install the operating system. Now, Oracle block is made up of OS blocks. Suppose Oracle block is 2 kilobyte. OS block is 512 MB, 512 kilobytes. Sorry, 512 bytes only, not kilobytes. So generally most of the operating systems use 512 bytes block size. So that means 4 OS blocks make up one Oracle block,
Okay.
right? Oracle block is 2 kilobyte.
Okay.
So that
Yeah.
means 4 OS blocks make up one Oracle block.
Okay. Does it have to be
Well,
always two
no,
period or?
Oracle database supports different block sizes. Minimum is 2
Okay.
kilobyte. 2
Okay.
kilobyte, 4 kilobyte, 8 kilobyte, 16 kilobyte, 32 kilobytes. These are the
Okay.
block sizes supported. Default, when you create the database, if you don't specify the Oracle data block size, default is 8 kilobyte.
Okay.
Assuming that operating system block size is say 1 MB, 1 kilobyte, sorry.
Okay.
Oracle block size is 8 kilobyte.
Hmm.
So how many OS blocks make up one Oracle block? It's 8.
8 blocks. 8
Yes.
blocks. Yeah.
Yeah. So that way you have to correlate. You have to correlate Oracle block with OS block to understand the space management. It may be a little bit confusing initially because for the first time in your life you are going through these concepts. It's okay. It's a normal, very normal. Okay, but after
Okay.
some time, these will be on your fingertips. Don't worry.
Sure. Sure.
All right. So now that you understood the high level terms, the high level concepts about instance and database. Okay. So database consists of physical storage structures, which include data files, control files, read log files. Also includes a logical storage structures. So the physical space is allocated using logical units called data blocks, extents, segments, and table spaces. And you know the meaning of each one of these and the relation among these at a very high level. So putting all these things together, right? Whatever we learned so far, let us put all these things together to understand how a client application or an user connects to database and how all these database structures like memory structures, background processes work together. So this diagram depicts all the concepts that we have gone through so far. You have two systems. Uh, we have client system. Just observe my cursor. This is the client system which runs the application, client
Yeah.
application. Now you have the database server. So both are physically different. Client system is different. Database server is different. They are communicating over network. So client system submits your SQLs. Ultimately, any application sends SQLs to the database. And this SQL will be processed inside the database server. Now inside the database server, you will have instance, right? Every client, every application, every user connects to the instance, right? And the
Yeah.
instance has memory structures and processes, background process and server process. Now you can
Okay.
see you have memory structures in the form of SGA and
Okay.
PGA. You can see the PGA. Then you have
Right.
processes. You have background processes. You have server process. And instance, this is instance part. You have database also. So instance communicates with the database. So that way you can see client communicates with instance or client connects to instance. When client connects, database starts a server process, right? So to be precise, client always communicates with the server process on the server side, which is
Okay.
in the instance. And this instance communicates with the database. So
Okay.
whatever we discussed in today's session are depicted in that diagram.
Okay.
So we'll stop it here for today and continue further in tomorrow's session.
Sure. Yeah.